Okay, today we're going to talk about angles of triangles. So check this out. Notice we have triangle ABC here. I've got the angles highlighted. And I have a straight angle right here. Now, one of the things to remember about a straight angle is it has a measure of 180 degrees. All right, so check this out. Do a little moving things here. And voila. We were able to fit those three angles onto that straight angle, which means if I combine the measures of those three angles, they will equal 180 degrees. This is what's called the triangle sum theorem. The sum of the angle measures of any triangle, every triangle is 180 degrees. So all the inside angles of a triangle, add them together, they will equal 180 degrees. Now, let's take a look at this. Notice how on triangle ABC here, we extended the side. And right here at C, it keeps going on through D. We've extended the side and created an exterior angle right there. So we're going to take measure of angle B, or A, and then B, and combine them together, and notice they fit into that exterior angle beautifully. That's called the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. The two angles that are furthest away from it, you combine those measures, and you've got the measure of that exterior angle. So let's take a look at a couple of examples. We're going to find the measure of each angle. And we're going to start off using the triangle sum theorem. Where x plus 100 plus 3x equals 180. Then using our algebra, we're going to combine like terms. The x and the 3x are 4x. Do a little subtraction. Subtract the 100 from both sides. And we have 4x equals 80. Now a little division. When we divide each side by 4, we find that x is 20. Now that's not our final answer. Remember, we want to find the measure of each angle. Well, we already know that the measure of angle N is 100 degrees. So looking at the measure of angle M, it's x, and we know that x is 20, so the measure of angle M is 20. The measure of angle L is 3 times x, or 3 times 20, which is 60. So right now, pause the video, and you try the other example there, triangle ABC. Okay, same process. Excuse me. Triangle sum theorem. X plus 2x plus 90 equals 180. Combine your like terms. 3x plus 90 equals 180. Subtract the 90. And we have 3x equals 90. A little dividing by 3. and x is 30. So again, looking for the measures of the angles. So we know measure of angle A is x, and x is 30, so the measure of angle A is 30. The measure of angle B is 2 times x, or 2 times 30, and it's 60, and we know that the measure of angle C is 90. All right. So we have corollaries. Corollaries are like little mini theorems. They are kind of a branch from a theorem. This first one here, the acute angles of a right triangle are complementary. Remember, complementary is 90. So that could give you a nice little shortcut. Oops, wrong direction. A nice little shortcut on the problems like this one with the right angle. It'd have been easier to go, hey, x plus 2x equals 90. We could have, gotten down to this step right here to save some work. But triangle sum theorem still works if you forget that those acute angles are complementary. Our other corollary, the measure of each angle of an equal angular triangle is 60, because 180 divided by 3 is 60. Now that's another thing to remember. Remember, every equiangular triangle is also equilateral. So when you come across an equilateral triangle in the future, you need to remember that, hey, all of those angles are 60. Little heads up. All right. So here, notice on this example, we have an extended side that has created that exterior angle. So we know if we take the two remote interior angles, like x, and add it to the 65, they will equal that exterior angle of 2x plus 10. And all we have to do is our algebra, subtract x from both sides. 65 equals x plus 10, subtract 10 from both sides, and we find that x is just 55. And that's all we had to do, is find the value of x. So on the other one, find the values of x, y, and z. The diagram is not to scale. None of the diagrams are to scale, just letting you know. So we're going to find x first, and we start by looking at this triangle right here. Looking at this first triangle right there. We can use the triangle sum theorem for that. So the triangle sum theorem tells us that 56 plus 38 plus x will equal 180 degrees. All right, so we combine our like terms. 56 plus 38 is 94. And then subtract that 94 from the 180. And we get x is 86. So right here, oops, is 86 degrees. Now, if we extended this side right here, extended it on, we created, y becomes that exterior angle. Okay, y becomes that exterior angle, and we know it's the sum of the two remote interior angles of 56 and 38, and look, we already have that right here. So by the exterior angle theorem, we can say y is 94. So it's 94 degrees. That does not look like a 94 degrees. So now to find z, can just use triangle sum theorem again. Or if you see that exterior angle, you can use the 86. But I'm going to use the triangle sum theorem. Sometimes it's just a little easier to see. So we can say 94 plus 19 equal plus z equals 180. Combine our like terms here. 113 plus z equals 180. Subtract that 113 from both sides. And z equals 67. So using a combination of the triangle sum theorem and the exterior angle theorem, you can work your way across a picture of a couple of triangles. All right, so right now pause and you can work this example. When you get done, restart the video. So these two angles are vertical angles, and all vertical angles are congruent. So that means that this one's 114, this one is 114. So remember, vertical angles, that's way back from like section 1-4. Yes, I still expect you to remember stuff from chapter 1. So now I'm using the triangle sum theorem. We know x plus 114 plus 47 equals 180. Combine the like terms. X plus 161 equals 180. Subtract the 161. And x equals 19. So 19 degrees here. Now again, let me say, all pictures are not drawn to scale. Okay, all pictures are not drawn to scale. All right, we're going to finish big. So we're going to find all the measures of all the angles there, 1 through 9, ones that are all red. And I'm going to write down everything I do. So I'm going to start right here with this triangle. And I'm going to find angle 1. One of the things I recognize is that this 125 is an exterior angle. So I'm going to start off using that exterior angle theorem. That tells me the 50 plus our unknown angle is going to equal the 125. So all I have to do is subtract 50 from both sides. And x is 75. Now I can use the triangle sum theorem to find angle 2. Now if you see other shortcuts to use, then you use those shortcuts. So we can go 50 plus 75 plus our unknown equals 180. We already know 50 and 75 are the 125. So subtract that 125. And x is 55. Or angle 2 is 55. Right here, right across, angle 2 and angle 3 are vertical angles. Angle 2 and angle 3 are vertical angles. Remember, all vertical angles are congruent. So angle 2 is congruent to angle 3. So that means angle 3 is also 55 degrees. So now to find 4, we can triangle sum theorem. So triangle sum theorem 55 plus 85 plus angle 4 equals 180. So combine your like terms, that's 140. Subtract the 140 from both sides, and our unknown angle is 40. I notice angle 4 and angle 6 are vertical angles. Angle 4 and angle 6 are vertical angles. So angle 4 is congruent to angle 6. So that means angle 6 should also be 40. Now if you notice right here, angle 4 and angle 5, and even angle 6 and angle 5, they form a linear pair. So angle 4 and angle 5, they form a linear pair. And one of the big things, the big thing about a linear pair is they are supplementary. So that means all we have to do is go 180 minus 40, and we get 140. So right now, pause, and you find 7, 8, and 9. So pause the video, and you try to find the measures for 7, 8, 9. When you have them, restart and check. So I'm going to find angle 8 first because I see vertical angles. So that means those two are 65. So then, let's say to find 7, I'm going to do the triangle sum theorem, which means 40 plus 65 plus the unknown angle 7 is 180. Combining our like terms, we get 105. Subtract the 105 from both sides. And we find our unknown angle of 7. Angle 7 is 75 degrees. Yeah. And another way, we can look for 9. You can see that it's a linear pair here and here, and all you would have to do is subtract 65 from 180, or if you use the exterior angle theorem, all you have to know is that 40 plus 75 is our exterior angle of 9 here, and that's 115. So you can use a combination of any of them. There's, more than one way of working some of these. If you see, vertical angles, take advantage of that. If you see the linear pair, they're supplementary, definitely take advantage of that. And then use triangle sum theorem or exterior angle theorem to finish out the bigger pictures. The assignment is a 4-2 assignment in ALEKS. It is due next class.